I'm going to tell you about Indigenous astronomy and navigation this morning. First of all, I'm going to tell you a bit about myself. So, my day job is to do research on astronomy. And so I do things like understand how black holes get into the galaxies and what they do to the galaxy and things like that. What I'm really interested in, as well as my astrophysics, is how different cultures get involved in astronomy, how they use astronomy. And it turns out that Indigenous people in Australia have been doing an awful lot of astronomy for 50,000 years or so. So let me start by giving you an example. This guy here on this slide is a guy called Bill Yidamduma Harney, and he's the senior elder of the Wardaman people in the Northern Territory. Now, Bill and I are actually great mates. We do a lot of work together. We actually did a stage show together. And you might think, you probably guessed from my accent already, I'm a Pom. I grew up in the suburbs of London. Bill grew up in the bush and went through initiation processes and all this stuff. And you think, well, how does a Pom and an Aboriginal elder get to be good mates? And the reason is that we both mad on the sky. We both love the sky. And we love it in different ways, but we exchange our stories. So I tell Bill my stories about black holes and electron jets and how galaxies form and the Big Bang and all that stuff. And Bill tells me stories like this. So in the Wardaman people's culture, when they die, they believe their spirits go up to the sky. Now, they don't just go up any old how. They go up, you can see on the screen behind, there's a star there on the right called, well, as an astronomer, I'll call it Vega. And Bill calls it Jalala. And he says it's not really a star at all, it's a tunnel, a wormhole or portal. And our spirits go up and through that portal and then into the Milky Way. And they spend ages up in the Milky Way going through ceremonies and things, repurifying them, getting them ready for their next life. And when they're ready, they come back down to Earth again as shooting stars. So if you haven't seen a shooting star, they're really easy to see. You just go out, you've got to find somewhere really dark, like in the bush, and just look up at the sky and you'll see this thing go pew, and they're bits of rock falling through the atmosphere. Anyway, so in Bill's culture, he believes these are spirits coming back to Earth. And when they come back to Earth, your spirit, when you come back to Earth, you land on the ground, you make your way to a creek. Now, while you're up in the sky, up in the Milky Way, you had a couple of other guys looking after you. There's star I call Altair, Bill calls Bullion, the wedge-tailed eagle, and that's like the top guy. He's the master of ceremonies. And the star I call Arcturus, Bill calls Munin, and he says it's a big rock cod living in the sky. And that's like your mentor, the guy who's looking after you. When you come back down to Earth, you land in the creek, and the big rock cods on Earth look after you, and they feed you algae. And you're going, yuck, why would I want to eat algae? Well, I didn't write this, right? I mean, I'd make it chocolate or something, but in the Wardaman tradition, it's algae. And anyway, you stay in the creek for a while, and you wait for your mother to come past. And when you recognise your mother, you jump up into her, and you become reborn. And so it's reincarnation. That's the Wardaman life cycle. It's a very beautiful story. And we find lots of stories like that right across Australia. Now, across Australia, there's not just one Aboriginal culture. There's about 300 or 400 different cultures. I've got a map here, the names of some of the people I'll be talking about in the next half hour. Bill's up there and the Wardaman people up near Catherine. So all these different groups, they've all got different stories. Now, so I'm just going to go to one right up near the top there in a place called Arnhem Land, east of Darwin, and a little community called Darlinboy. You might wonder what an Aboriginal community looks like if you don't live in one. We hear an awful lot on the news about problems in Aboriginal communities, and it's really nice to know that there's Aboriginal communities like Darlinboy here which don't have those problems, and of course they don't get on the news because they don't have problems. And the kids here, you can see they're happy and well fed, and they go to school every day. There's a couple of teachers come in. This is about 300 kilometres from the nearest road, so it's a pretty remote community. They have a school there. All the kids go to school there, and some of their lessons are in English, which they're learning as a second language, and some of their lessons are in their first language, which is Yolngu, which is the language spoken by the people up there. And they have wise and careful elders who are trying to find the right direction for their community. It's a beautiful community. Anyway, so let's go to a couple of stories that the young new people might tell us about. So one of them is called the Emu in the Sky. So if you look at that picture in front of you, what you've got is the Milky Way. So you look up in the sky, and right now it's a little bit early. A couple of months' time in the evening, you look up. If you're out in the bush, you've got to get away from the streetlights, and you see this beautiful Milky Way going across the sky above you. And you'll see in it, it's got those dark clouds. And those dark clouds are caused by dust in our galaxy where new stars have been born. Now, just to orient you, on the right there, the top right, is the Southern Cross. So if you go out this evening, if you look down roughly in the south, you'll see the Southern Cross there. The Southern Cross is roughly in the south of the sky. And if you're out in the bush, if you look carefully, you'll see next to the Southern Cross is that dark cloud. I'll just take those dots away so you can see it. See that black bit just below the Southern Cross up on the right? Okay, there's the Southern Cross on the top right, and just below it is that dark bit just next to those two stars. And that's the head of the emu. Can you see, if you look carefully, you can see that the head of the emu's got a beak sticking out to the right. Then following down to the left, you've got the neck, all those dark clouds. Remember, you're looking at the clouds, not the stars, the dark spaces. This constellation is made of the dark spaces, and that goes into a sort of round bit. That's the body of the emu, and the legs go off to the left. I'll just draw it on it. If you haven't seen it yet, that's what it looks like. Okay, so let me just go back to that picture. Can you see the emu? Now, if you go out into the bush, and you've got to get away from the streetlights, if you look up in the sky, you'll see this emu stretching across the sky, and you go out there and you'll be looking for this, where's this thing that bloke Norris was talking about? And you'll be looking around, and you see the Southern Cross, and suddenly you realise the emu is not a little thing you were looking for. It's this thing going right across the sky. It's absolutely enormous, stretches right across the sky. And it's the most fantastic sight. And if you haven't seen it, I really recommend you go out one day. Do it in a couple months' time, like May, and that's the best time to see it on a really dark evening. Okay, so the emu is a really important constellation. It's right across Australia, and it's to do with all sorts of things like initiation, things like this. Lots of stories. Every group's got a different story about it. So around Sydney, we have a lot of things like rock engravings. You can see there's a man on the right, and there's a wallaby and its baby on the left. We find these rock carvings all around Sydney. There's thousands of them. And these were made by Aboriginal people hundreds or thousands of years ago. And up in Ku-ring-gai National Park, just north of Sydney, is the engraving on the, which you can't see very well on this picture on the bottom, you can just see there is an engraving, is a picture of the emu. And it's an emu on its side. You see it better in a second. But the interesting thing is that, there you go, see the outline there, is that real emus don't really look like that. Real emus look like that. They never have their legs behind them, but the emu in the sky does have its legs behind it, and we think that's actually a picture of the emu in the sky. So Aboriginal people didn't just talk about these constellations, they also drew them in the ground. And in fact, this particular site, for any of you who live around the Sydney area, you should go up there, it's fantastic. It's the Alvina track. When you go up to the West Head, towards West Head, it's the first track on your right, it's called the Alvina track. You go along there and you find all these beautiful Aboriginal engravings. Now, I was a little bit sceptical when I first heard about this. I thought, well, yeah, okay, could be. But the thing that really got me is actually the emu, in this picture here, you see the emu in the sky above the emu on the ground, and this is just how it looks in late autumn, and that's when the real-life emus lay their eggs, and that's a really important food source for the local people. So it's circumstantial evidence, but it sort of hangs together. Okay, let's go to another constellation. So like Orion. So the reason it's called Orion, you see it actually at the moment, it's sort of near the moon right now. It's up in the sky in the evening. And the thing that's most obvious, those three stars in a line. So look at the moon, look near the moon, and you'll see a line of three bright stars, and that's the belt of Orion. And the reason we call it Orion is because it's from Greek mythology, and there's this hunter who's a Greek hunter, and those three stars are supposed to be his belt, and the Orion Nebula is his sword, and the other stars his arms and legs and so on. But you need a pretty good imagination to turn that pattern of stars into a Greek hunter. And there's also something really wrong about this picture. Now, I don't know whether anybody can see it, but Orion is upside down in the southern hemisphere in Australia. So, in fact, you're not even trying to turn that pattern of stars into a hunter. You're trying to turn it into an upside down Greek hunter. You know, it's not the thing that obviously springs to mind. Okay, so that's why maybe not many people knew the name of the constellation. In Australia, we often call it the saucepan. And the saucepan's good, it's the right way up. It's much better than an upside down Greek hunter. Anyway, Aboriginal people thousands of years ago didn't have saucepans, and so they had other names. And everybody's got their own story about Orion. And I'll tell you the only one from Darling Boy, which that village I just spoke to you about. And they see it as a canoe. So those three bright stars, they say, are three brothers sitting in a canoe. And these three boys, they were going out hunting and fishing, and all they could catch were kingfish. So up in Arnhem Land, people see the constellation of Orion as being this canoe with three brothers. And the three brothers are from the kingfish clan. So you can't eat kingfish. It's like, means they're descended from the kingfish back in the dreaming. So eat kingfish, it's like eating your grandfather, you know. It's like, yuck. It's also extremely illegal. And anyway, one of the brothers got so hungry, all they could catch were kingfish, and he ate one. And the sun saw this, the sun's female in most Aboriginal cultures, and she blew them up into the sky. And so when you see the constellation of Orion, what you're seeing are those three brothers in their canoe with the fish on the line behind them, and they've been put up there as a punishment for breaking the law. And I'll take away that picture. Can you see the canoe there? So when you go out tonight, you don't actually, even if there's streetlights, you can still see it. You see those three bright stars near the moon, and those three bright stars are the three brothers in Orion. And it really looks much more like a canoe than a saucepan or an upside-down Greek hunter. Anyway, okay, so these stories about the sky, these are great, they're very interesting, they're lovely, but is it astronomy? It's not the astronomy I know. The astronomy I know, when I do astrophysics, I want to know about how the sky works. I want to know how galaxies work. I want to know how the universe started. I want to know why eclipses work and why the tides work and why do we have seasons? Why do we have day and night? Those are the sorts of things we do in astronomy. And then the other thing about astronomy is that it's useful. We use it for navigation. We've used the discoveries from astronomy to get GPS and things like that. So is there any evidence that Aboriginal people thousands of years ago were doing more than telling stories? Were they actually trying to understand the sky? And that's what our research project, me and several colleagues, that's what we're working on, trying to understand, is there astronomy in Aboriginal culture? Okay, I'll illustrate what I mean by telling you about another constellation, a group of stars called the Seven Sisters. And they're close to Orion, but you need to be right out away from the streetlights to see them. Beautiful little cluster of stars. And they're called the Seven Sisters, or the Pleiades. And the reason they're called that is because, again, in Greek mythology, they were this group of seven beautiful girls, and those are the seven stars that you saw, very beautiful. Of course, being Greek mythology, in Australia they're upside down. And they were being chased by Orion, like boys chase girls, right? And so the story is that Orion was chasing these seven girls, and they escaped up into the sky. And in fact, as the sky goes round, you see Orion following the Seven Sisters. Here's a Yolngu story about the Seven Sisters. And this Yolngu lady is telling us that the Seven Sisters, they come back with turtle, fish, and so on. Well, you can read it there. The point is that the Yolngu people know that when they see these stars in the sky, it's time for all these foods to come out, the berries and so on to come out. And you might think, well, why do they need to know that? Can't they just see the berries on the trees? Well, no, actually, because these people are hunter-gatherers, which means throughout the year, they travel in a cycle around their land, and they need to know when it's time to move from one place to another. They need to know when it's time to go up to the escarpments to get berries before the birds will get them, or when it's time to come down to the rivers where there's the barramundi before the barramundi all swim out to sea, and so on. So calendars are really important to hunter-gatherers, and so in fact they have calendars and they use stars like the Seven Sisters to tell them when it's time to move camp. Now, and here's another story. It's from another place in Northern Territory, and the guy here is saying, you see that mob of stars? That's Orion. We blackfellas call him Man Book, and all day he chases that mob of girls over there, Seven Sisters. Again, same story. And we find this story all over Australia, that Orion is nearly always, the story changes a little bit, but Orion is nearly always a young man or a group of young men, and that other cluster is a group of girls, and the boys are chasing the girls. And you think, well, why do you get the same story everywhere? And then you realise, hang on, that's the same as the Greek story. And actually you find the same story in China and everywhere around the world. It's really weird. And what's even weirder is that Seven Sisters, they really don't look like seven. If I've just gone back to the slide, if you look, there's no way you make that Seven Sisters. There's not seven stars there. If you've got really bad eyesight, you might see, well, if you've got really bad eyesight, you just see it as a little smudge. Or maybe you see 4 stars or 5 stars, or maybe you see lots of stars, but nobody sees it as 7. And so why does everyone in the world call them Seven Sisters and have these same stories? One of the bits of research I've done is we know about how these stars evolve. Was there some time in the past when they looked like there were 7? Not as far as we can tell, but they may have varied in brightness to make them. But why do you get the story all around the world? Because in fact the Aboriginal people didn't have very much contact with the Europeans for like 50,000 years. And so we think this story might be really, really old. It might predate the Aboriginal people coming to Australia. It might actually be from 100,000 years ago when all humans came out of Africa. So 100,000 years ago, all of us with whether we're Asians or Europeans or Aboriginal people, we were all sitting around our campfires 100,000 years ago in Africa telling each other these stories, and all our cultures have still got these stories. Okay, let's move on. When I'm telling you this, you have to be aware of some cultural baggage. Sometimes you'll hear people say things like, no Aboriginal languages have words for numbers higher than 4. Aboriginal people couldn't count beyond 4 or 5. They go 1, 2, 3, 4, many. You get stories like that around. They're completely wrong. This picture here is actually of a group of kids in the Tiwi Islands, North Australia, and with my wife on the right there. And they're doing this game, which I guess probably all of you do. You jump into the pool, you put your heads below the pool, and you see who can hold their breath the longest. And these kids were doing this, and they only spoke Tiwi. Hang on, our guidebook had just told us they can't count beyond 5. So kid puts his head under the water, and the kids around him start counting Tiwi. 1, 2, 3, 4, 5. What do they do when they get to 5? Because our guidebook says they can't count beyond 5. They just kept on going. It's complete rubbish. These are the Tiwi numbers up to 10. And in fact, Tiwi people can count up to 100 or 1,000 or whatever. And so you have to be really careful. There's this baggage going around that people underestimate Aboriginal cultures. I think it's something left over from colonial days. And Aboriginal people really can count. They do make measurements. They are interested in how the world works. Okay, myth busted. Let's move on. What about the moon? Aboriginal people saw the moon changing every day. It starts off as right now, it's a really big, bright moon. It gets to be a full moon, big and round, and then gradually, over a period of a month, it gets thinner and thinner, becomes like a crescent, and then goes dark for about 3 days, 3 nights, and then it gets brighter again. And there's stories about why this happens. Let me tell you one, again from Arnhem Land. So, the moon, the one particular story, lots of different stories, but the one story is that the moon was this really lazy man, and he wouldn't get any food. And his wives and his sons had to get all the food. And they got really annoyed about this. He was just so lazy, sat around all the time. So they stopped chopping bits off him, as he would. They got their knives and chopped bits off the moon, And he got thinner and thinner, and then he died, and then he became the new moon. And this fat man, he's a really bad man, Nyalinda he's called in Yolngu, and he came back to life, and he cursed the world. He actually brought death to the world. And he said, from now on, I'm going to come back to life every month, but nobody else will. Okay, that's the only story. You get similar stories from all the other cultures in Australia. They nearly always involve the moon being a bad man. So my wife and I were, a few years ago, trying to understand all this. This is us up in Arnhem Land in our rental car, crossing a creek across the road. That creek, by the way, is full of crocodiles. So you really don't stall the car in the middle of the creek. And we were trying to understand things like how the tides work. Well, we know now how the tides work. Scientists will tell you it's all about gravitational forces from the sun and the moon. What we know with the tides, if you live near the sea, you see the sun. You see the sea going up and down by about a metre or so every day, actually twice a day. And the height of the sea goes up and down twice a day. And we know the height it goes to depends on the phase of the moon. If you've got a full moon, the tides go up and down an awful lot like that. If you've got a crescent moon, it only goes up and down a little bit. And so people have always tried to figure out, how do these tides work? Now, many of you will know of Galileo. He was maybe the world's greatest ever scientist. He did things like use the telescope to find the moons of Jupiter. And he really took an approach of really looking at the world and trying to understand how the world worked, using experiments and using observations rather than just guessing. And I think he had a really bad day one day. He was trying to figure out how tides work. People around him, like Kepler, were saying the tides were caused by the moon. Galileo didn't believe them. He said, that's a lamentable piece of mysticism. He's Italian, so he said it in Italian, but you get the idea. And it's really stupid. He had this stupid model which really didn't work. It only gave you one tide a day. Didn't tell you when it's going to be high or low. Galileo didn't think you could actually understand that stuff. All right, so that was Galileo's biggest blunder. What about the Yolngu people? So one of the things we were interested in, how do the Yolngu people see tides? Well, they have an interesting explanation. They live on the east coast of Australia, and they see the moon coming up through the horizon every day. And they've noticed that the tides, and the moon comes up different time each day, they've noticed the tides happen at the same time relative to the moon every day. You get 2 tides a day, and it depends on where the moon is. And they've also noticed that when it's a full moon, you get a really big tide, and when it's a crescent moon, you don't get such a big tide. So they've got this explanation involving the moon filling up with water as it goes up through the horizon. Now, you might say, well, that's a bit of a funny explanation because it's not what we know now. No, but given the information they had at the time, it's actually a really good explanation. And you imagine if you were there, you didn't know about orbits, but you saw the moon going up every day, and you'd noticed that when there was a full moon, it was a really big tide. And you think, that must be why the moon is getting full, or why we're having a new moon. Must be something to do with it. And so you come up with a model like this. Okay? Now, the point is, this is science. You might not like the explanation, but the science is right. With the information they had, it's a perfectly good scientific explanation. What's more, it has predictive power, which is one of the other things we want from science. A young new person can look at the moon, and from the moon they know what time the tide's going to be, and they know how big the tide is going to be. So it works. This is how science works. If you want to understand how science works, this is a really good example. With the information you've got, you figure out how what you see in the sky is related to the things that are going on around you, and you're trying to make it useful. So that the explanation works. Galileo's didn't. Right. So let's move on. So one of the things I wondered, could people actually predict where things rose and set on the horizon? And there's this fantastic site down in Victoria, a place called Wurdi I don't know whether it's a ring of stones, still slightly kite-shaped ring of stones. I'll just draw a circle on it so you can see it. And I'll take that off. So it's this ring of stones about 50 metres across. The biggest stones are up there at the top, and they're about 1 metre high. They're weighing several tons. Big ring of stones. Now, the amazing thing about this ring of stones is that if you stand at those 3 stones at the top and you look out, and you see some other stones running away from you there, and when you look out over those stones, you see the places where the sun sets. What this shows is that the people who built this circle, they put in stones in the ground to point to where the sun sets on these special days, on Midsummer's Day, on Midwinter's Day, and the equinox. And this is amazing. This shows that Aboriginal people who built this stone circle thousands of years ago, they are actually, well, firstly, they're interested in the motion of the sun, and secondly, they were measuring its position. They're actually marking things on the ground. This place is sometimes called an Aboriginal Stonehenge, because it's a bit like the Stonehenge in England. Well, being a scientist, I'm always a little bit sceptical of these things. And you think, well, could it be by chance? Could it be a hoax? Well, you go through all these things. And so we did a lot of work on it. We made the big survey. And you see the picture up now. That shows our plan, and it's a pretty wonky circle. On the left are the 3 lines that I just showed you. So you stand at those big 3 stones, you're looking out over the little stones, and you've got those lines pointed towards the setting sun on Midsummer's Day and Midwinter's Day. But it's just not just those little stones. On the right, you can see those big lines, and they're fitted to all the stones in the circle. And the circle isn't really a circle, it's got these straight bits. And so when you look out along those straight bits, you're also looking at where the sun sets on Midwinter's Day and Midsummer's Day and at the equinox. So this circle is clearly built for this purpose, and it's not by chance. And then we did a whole load of statistics and things, which I won't bore you with, and we showed, it really isn't by chance. I'll show you what that looks like. If you stand down at the pointy bit of the circle, and I don't know whether you can see those 3 big stones on the horizon there. So on the equinox, the sun sets like this, just right behind those 3 stones. It's exactly right. Or if you look up one of those straight lines of stones here on Midsummer's Day, and you wait for the sun to set. It's Melbourne, so it's a bit grey really, but you still see the sun sometimes. And you see the sun setting just behind that row of stones. So this stone circle is clearly built. It is really important to these people who built it. We don't know anything else about them, unfortunately. We don't know why they did it. Why are they interested in the sun? We don't know. And that's one of the great mysteries we're trying to understand. And it's done accurately. And so you can ask, how well do people elsewhere in Australia know direction that well? So my colleagues and I did this big study of other stone arrangements. So all over New South Wales, you get these lines of stones, and you see some of them on the right there. And there's a sort of folklore that these things tended to point to the north. And we thought, well, being scientists, how true is that? Can we measure that? And so we went around a whole load of these, and we measured what direction they're pointing in. And this is a histogram showing all the directions. Now, I'm hoping everybody likes histograms. If you don't like histograms, shut your eyes, it won't hurt you, it will go away in a minute. But actually, histograms are really useful things. So what we've done is along the bottom is the azimuth, the bearing. So on the left, 0, that's north-south, and in the middle, 90, is east-west. And for every stone row, we've put a point at the bearing of that stone row. And what you can see is that a whole load of them pile up at 0, at north-south, and a whole pile of them pile up at 90 degrees, that's east-west. And so that's showing that these stone rows, they really are. When the Aboriginal people built these stone rows, they built them either north, or on the whole, there's lots of others there, mostly built them either north-south or east-west. The really interesting thing is that the widths of those piles on the histogram are about 5 degrees. So that's telling you that the Aboriginal people weren't just interested in north, south and east, west, but they also knew those directions really accurately. How can you measure east, west to an accuracy of 5 degrees? You might say, you look at the setting sun. No, wrong. Setting sun can be anywhere from northwest to southwest. If you want to get it to 5 degrees, you've actually got to make some really careful measurements. They've got to do the sort of stuff we've just seen at Wurdi Youang. So it's showing that people all over New South Wales were making astronomical measurements, so they knew these directions within a few degrees. Well, that navigation. So that's my mate Bill Harney again here, and he says, each night, I'm not going to say his accent, it'd be awful. Each night where we're going to travel back to the camp, otherwise you don't get lost, and the only tell is about a star. How to travel, follow the star line. Let's remember, English is his second language, so it's not perfect. But the point is, Bill knows the sky really well. I'm actually paid by CSIRO as an astronomer. You might say, wow, that guy Norris must know so many stars. Well, I don't actually. I do everything on a computer screen. I'd be lucky if I can point out name 20 stars for you, probably. Bill knows every star in the sky. Every star you can see down to about 4th magnitude, Bill has a name for, thousands of stars. So Bill knows the sky much better than I do. And he uses this to navigate. He uses this to get directions, and he knows what constellations he has to follow to get to his camp and things like that. You get other questions. People might ask, why is Venus always low in the sky? So Venus, if you watch the setting sun tonight or last night, you'll see this really bright star just above it, and that's Venus. And the thing about Venus is it's always just above the setting sun, or early in the morning, it rises just before the sun. But you never see Venus up there. It's always low in the sky next to the sun. And the Olney people saw this, and they were obviously trying to figure out, why is Venus always low in the sky? So they have this story about Venus. They call Venus Barnabia, and they say she's a creator spirit. She came from the east. She actually brought the first humans to Australia. And when she rises up in the sky, like that, I hope you can see it, there's actually a line underneath Venus going down to the horizon. And they say the reason Venus doesn't go high in the sky is because there's a rope attached to her, and the rope stops her flying too high. The rope's actually put there by her sisters to stop her accidentally getting lost. And, well, that's an interesting story, but I'm an astronomer. I know there isn't a rope hanging down from Venus. I said this to one of my Yolngu friends. I said, well, yeah, lovely story, but there's no rope. And my Yolngu friend said, yeah, there is. You haven't looked hard enough. I said, look, I use things like the Hubble Space Telescope. I know there is no rope underneath Venus. I'm an astronomer. I know about these things. And she said, well, you haven't looked hard enough. Oh, well, next morning, 4 o'clock, we're out there at dawn, watching Venus rising. And I know I'm an astronomer. I'd completely forgotten. There's this thing called zodiacal light. If you're in a really dark place, when Venus rises, up behind it is this glow of light. It's actually caused by dust in the solar system, and you get light being reflected off the dust, and you get this beam of light up the horizon, up towards Venus. And she was totally right. There really is this beam of light holding Venus down. So, right, Yolngu 1, Ray 0. But the other thing about Barnabia, as she crossed the land, she sang this song. And she, in the myth, she's flying over the land, and she describes the mountains and the waterholes and the good camping ground and the places you don't want to go to because they're swampy. And this becomes like a sort of oral map. So if you know the words of this song, you want to navigate across Australia, you go through the words of this song and you come to a mountain and you remember, oh yes, Barnabia said you go to the right of this mountain and there's this really good camping ground, and you don't go to the left because it's all swampy, and so on. And these lines marked out by these songs are a way of navigating. They're called songlines. And we know lots of these. Here's one we've got in New South Wales. Now, that goes from Carnarvon Gorge up in Queensland, down through Roma, Surat, down to Waduga in northern New South Wales. We've been working with the Kamilaroi and Yualai people up in northern New South Wales, where they're trying to rebuild their culture. It's really badly damaged by the Europeans coming, and we're helping by trying to pull the astronomy together. And so we actually mark out these song lines, and there's a song which tells you how to navigate from Carnarvon Gorge down to Waduga. And in fact, this song is also marked up in the sky in the constellation Scorpius there on the left. I could tell you lots more stories like this. Bill Harney remembers as a kid how he was navigating across the north of Australia with his grandfather, and the whitefellas wanted to build a road, and they wanted to do an Aboriginal guide, and his grandfather just followed this song line, and the white guys behind him, they knocked down the trees and built this road. That road is now the Victoria Highway. That follows an Aboriginal song line. So does the Great Western Highway from Sydney up to the Blue Mountains. They're both song lines. I'm going to finish there. What I hope I've shown you is that astronomy is really important in a lot of Aboriginal cultures. The elders knew the sky really well. They tried to understand how the sky works. I call it ethnoscience. It's like science, but of course within the culture. They understood how eclipses and tides, I haven't told you about eclipses, but there are other stories about eclipses, and they use this knowledge for navigation. And I'm going to stop there and ask if you've got any questions. Thank you. If you go up to Ku-ring-gai National Park, which is just north of Sydney, about 20 kilometres north of Sydney, and there's two ways into the park. You go up towards West Head. You go up the West Head Road. The first track off to the right is the Elvina track. You go along there, and about 200 metres from the road, there's a path off to the right. You follow that path, and you'll see the emu there, and you'll see hundreds of other rock carvings. If you Google Sydney rock engravings, you'll find maps and things like that. Also national parks, people can tell you about them. The other really good track to go up there is if you go further up towards West Head, there's the Basin track on the right. If you go up the Basin track, there's a lovely boardwalk, lots of Aboriginal engravings, including some astronomical ones, and there's national park signs explaining what they are. So I mentioned eclipses, and there's this, and Aboriginal people did understand eclipses. So when you get a total solar eclipse, they say it's the sun woman and the moon man getting together and having a cuddle, and you get the body of the moon man covering the sun woman, and that's what causes the eclipse. And of course that expression is completely correct. You know, that's what causes a total eclipse. It's when the moon comes in front of the sun. And the amazing thing about that is that in any one place you only see a total eclipse maybe once every 10 generations. And it's weird that they have these stories that go across all these generations, across thousands of years, explaining how eclipses work. If you mean, are there other civilizations out there in space? My guess is almost certainly. You know, you just look at the number of stars, the number of planets, number of galaxies, you do the maths. Unless we're really, really, really special and improbable, there have to be other civilizations out there. But as far as we know, they've never visited the Earth. You know, I'm a scientist, right? I'm skeptical. I need evidence. And all these fuzzy photos don't do much for me. One day, maybe we will contact another alien civilization. I really hope so. It's going to be so cool talking to another civilization. But so far, we haven't done it. So, how did the Aboriginal people use the stars to tell when to harvest? So the answer is yes, they did have lots of different stars. So different Aboriginal groups, they have calendars and seasons like we do. Often they have 6 seasons in the year, and they'll say when a particular star comes up above the horizon in the morning, that's the time when you need to harvest something. So they have a whole load of different stars or constellations for these different things. For example, the star spiker, for the young people, when they see the star spiker in the evening, they know that's the time to go down to the rivers to get the nuts from the lotus plants that grow there. And the thing is, you can't actually tell from looking at the river when the nuts are ready, but you can tell by looking at when the stars are in the sky. If they leave it too late, then the magpie geese eat them instead. So they've got to get there in time, they've got to get there at the right time. So the stars are absolutely essential for that. Great question. Yeah, so people have stories, but I'm trying to remember them now. You've got me now. There are stories, and I can't remember any of them. But yes, so people have stories about what those pictures mean. Oh, so one of them was, the moon was attacked because he's a really bad man, and some of those things are scars from where he was attacked. That's one of the stories. You get different stories around. The other thing you get, I don't know if you've ever seen it, in the winter especially, you'll sometimes see a bright ring around the moon, a halo. And scientists would say that's light's been scattered off ice particles in the atmosphere. You only get it when it's quite cold. And there's a story that actually the moon man has built himself a wind shelter. It's a really cold night. and what you're seeing is the little hut or shelter that he's built around himself. There's lots of stories like that, yeah. So people often think, you've got the sun and the moon, the sun's up there in the day and the moon's up there in the night. Well, it's not right. I mean, as the person who's asked that question, you've noticed that does not happen. And you'll get nights when there's no moon in the sky, and sometimes the moon's up in the day. So as seen from the Earth, the sun's going round, obviously, and that defines our day and night. We call it day when the sun is up there. And the moon is going round its own path, which is quite different. And sometimes they'll be on opposite sides. When they're on opposite sides, and that's when you have a full moon, if you think about it. And when it's a full moon, the moon will be up in the sky during the night. It'll be right up above you at midnight. And other times the moon will be close to the sun, and that's when you see a crescent, and then the moon will actually be up in the day, except you can't see the moon very well when it's high up in the sky, but you can see it when it's slow down. The moon actually has got this funny motion. It goes all over the place. I was talking about eclipses earlier. One of the stories is that when you get a lunar eclipse, it's the sun woman chasing the moon man, and he's trying to escape. He's running backwards and forwards. This is the complex motion of the moon. And when she eventually catches him, and that's obviously when you've got the sun and the moon close together in the sky, and she catches him, and that's when you get a lunar eclipse. Well, not enough, actually, is the short answer. But a slightly longer answer is we're doing everything we can. The trouble is, you've got a few things. So firstly, a lot of this knowledge is known by the old people, and the old people, sadly, are passing on. And so it's a race against time to write this stuff down. And this is part of the reason we're doing this work, and going up and writing down the pictures, writing down the stories from these old people. And then there are other people, I'm just looking at the astronomy, lots of other people in different fields. Some people going around making recordings, making films, making recordings, people singing their songs and things like this. Then you get other groups. I mentioned earlier we're working with the Kamilaroi and Ualalai people in North New South Wales, and they're trying to rebuild their culture. Their culture was really badly damaged by the British and the Australians, White Australians when they came in. But there are enough people who know the language. They're old Kamilaroi people over in the west of New South Wales who still speak Kamilaroi as their first language. And so you've got younger people that we're working with, and they're learning that language. And I've spoken to guys in their 40s who who speak fluent Kamilaroi. They've learnt it, they can have a good conversation in it. And one of our goals with this project is we hope that in maybe 10 years' time or something like that, kids in Kamilaroi country in New South Wales schools will be learning Kamilaroi language as a second language, like you learn French and German and Chinese at the moment. One of your options will be Kamilaroi. And wouldn't it be great if we could do that all across Australia, that we could revive these old Aboriginal languages and celebrate the culture and make sure the culture survives. So there's lots of groups trying to do that. Of course, there's never enough people, there's never enough money, but yeah, people are trying really hard to do that. Really good question. Do you want the science answer or the Aboriginal answer? So the science answer is there was, I forget, I think it's 3.5 billion years ago, there's a big collision and with the Earth and another chunk of big rock, and the moon was expelled as a result of that collision, and it's now going around the Earth. The Aboriginal story, there's a whole load of different ones. One is that, as I said, the moon man was this really bad guy, and people were chasing him, and he ran up a tree, a really tall tree, tried to escape these people, and then he jumped up into the sky, and that's how he got up there. And he stays up there because he knows if he comes down to Earth, he'll be attacked again. Would you really want to? It's an awful place. I wouldn't want to go there. There's no air. There's no shops. But I don't think... I mean, you could inhabit the moon. You could set up a base there. And there are reasons that you might want to set up mining bases or something like that. But if you want to go and live somewhere else, actually Mars is a much better idea. Mars is a much nicer place than the moon. And people are seriously thinking about, should we set up bases on Mars? It's got a decent gravity and things like this. It's got a bit of atmosphere. It's a much easier place to live on than the moon. My guess is, I know it's a long time away. There's no technological reason why you shouldn't do it. You could do it now, actually. It's money. The thing that stops you is money. And of course, in the world we've got lots of other problems, other things we want to spend money on. And so it's always a toss-up. But my guess is eventually people go back to the moon, people go back to Mars. And there's a lot of science you could do. There's a lot of commercial stuff like mining rare minerals and things that you could do there. And of course, there's also debate, should we do it? Should we leave them pristine? It's a bit like, should you mine in a national park? It says an awful lot of complex questions. Not everybody thinks we should be mining in space. Some people think we should be leaving them alone. So the debate will go on. My guess is that within, maybe not in my lifespan, but in the lifetime of most of you guys, you'll see people living on the moon and maybe Mars. A long time. How long does it take? I don't know. I'll have to take that question on notice, I think. But actually, no, I'm going to set it an exercise for you. You know how you Google the moon, find its diameter. You know how fast you can walk, maybe 5 kilometers an hour or something, and work it out. Exercise for the students, okay? That's your homework. Hey, thanks for your great questions, really good questions, and it's been great talking to you. Thank you very much. Bye.